Okay, when we left off last time, we were dealing with simplifying square roots. Now we're going to deal with simplifying our cube roots. They're going to be set up the same way. So I'm going to start with my cube root of x to the sixth. I'm going to rewrite this as the cube root of x written out 6 times. When I had square roots, I put my x's into groups of 2. But now that my index is a 3, I'm going to put my x's into groups of 3. So for x6, I have 1 group and 2 groups. You'll notice that there's nothing left over. Therefore, my answer is x squared. The number of groups is still my exponent. We'll do this again with x to the 9th. For the cube root of x to the 9th, I'm going to write out x 9 times. Once again with cube roots, I deal with putting my x's into groups of 3. When I do this, I'll have 3 groups with nothing left over. So my answer is x to the 3rd. Take a minute to try x to the 12th. When you're drawing your 12 x's, make sure that you count them so that you actually have 12. Sometimes when we're drawing a high number, we forget 1 or 2 of them. When you're dealing with cube roots, make sure you're putting them in groups of 3. How many groups did we end up with for x to the 12th? You'll notice there's 4 groups, so you should have written down x to the 4th as your answer. You'll notice that all 3 of these first examples, 6, 9, 12, worked out into whole groups. We're going to look next at what happens when you have extras. Let's do x to the 7th. We're going to draw out our 7 x's again. And we're going to start by putting them into groups. My first group and my second group. So I have 2 groups and I have 1 extra. If you remember what happened with our square roots, anything extra stays inside of the radical sign. So my 2 groups is going to give me x squared, and my 1 extra is going to stay inside the cube root symbol. This would be my answer when I simplify it. This is the same idea as when we did square roots. Let's try x to the 8th together. I'm going to draw my 8 x's. And I'm going to put them in groups of 3. I'll notice I have 2 groups and 2 extra. My 2 groups give me x squared, and my extras stay inside this cube root house. Do not forget to put your 3 on top of the radical. For cube roots, you could have 1 extra or you could have 2 extra. When you're making groups of 3, you could have 1 extra or you could have 2 extra. Take a minute to try number cube root of x to the 10th. After I have my 10 x's, I split them into groups of 3. You should have noticed with 10 x's, you had 3 groups and 1 extra. So you should have written down for an answer x to the third and then cube root of x1. If you don't want to write the exponent of 1, you do not have to. That is an optional exponent. I like to write them just so that I remember that it is only 1 there, as opposed to having 2 extras. But that is your decision. Next, we're going to look at cube roots that have both letters and numbers in them, just like we did when we were simplifying our square roots. I'm doing the cube root of 27 x to the third. When I did square roots, I separated these into the cube root of 27 and the cube root of x to the third. I'm going to do the same idea. Make sure when you do x to the third, write out your 3 x's. So I'm going to go to my calculator and I'm going to type in the cube root of 27 to see if it's a perfect cube. As a reminder, your cube root button is math, and then it's the 4th option down. My cube root of 27 is 3. If I have the cube root of x to the third, I have 3 x's, which makes 1 group, so I have x1. For my final answer, I'm just going to smush these together into one final problem. Let's try the next example. I have the cube root of 54x to the 9th. So I'm going to separate this into the cube root of 54 and the cube root and draw out my 9 x's. When I type the cube root of 54 in my calculator, I notice that it's a decimal. So I need to remember how I simplified cube roots. First thing I need to do is make my list of perfect cubes. I'm going to start at the bottom because I know 54 is a smaller number. So I'm going to start with 2 times 2 times 2, which is 8. Then 3 times 3 times 3, which is 27. Keep building your list up from here. 4 times 4 times 4 would give me 64. And I now see that 54 fits right in between here. So I'm going to do my division. 54 divided by 27. And I'm going to see if I get a whole number or a decimal. I'm lucky enough to get a whole number on the first try. So I'm going to take 54 and separate it into 27 and 2. Don't forget to put both of these numbers back inside of the cube root. I'm going to simplify the square root of the cube root of 27, either in my calculator or if I remember. So the cube root of 27 is 3. The cube root of 2 is going to be a decimal, so I'm going to leave it as the cube root of 2. There's nothing else I can do with the 54, so I'm going to move over to the x's. I'm dealing with cube root, so I need to do groups of 3. 1 group, 2 groups, 3 groups. So if I have a total of x to the third. I have nothing left over, so I don't need a cube root for this portion. Now if you'll remember, when I write my final answer, I need to put all of this together. Anything not under the square root, I'm going to write first. So I'm going to write my 3 and my x to the third. Anything that was under the cube root, I'm going to write second. So my final answer would be 3x cubed, cube root of 2. Take a few minutes to try the next 2 problems. Be ready to check your answers. If you need additional time, please pause the video while you work. Use these 2 examples to help you with the next 2 problems. As a reminder, if you need more time, please pause the video now, as the answers to the next 2 problems will appear on the screen. When you did the cube root of 125, x to the 6th, you'll notice that cube root of 125 was a perfect cube, and the 6 x's split into 2 perfect groups. There was nothing left over. Therefore, your final answer is just 5x squared. When you did the cube root of 192, x to the 5th, 192 split into 64 and 3. Make sure you drew out your list. Cube root of 64 is 4. Cube root of 3 stays as cube root of 3. For the x's, when we had 5 of them, that created one group, and I had 2 x's left over. So I had x1 on the outside, and then x squared left underneath the cube root symbol. When you write your final answer, you only need to draw the cube root symbol once. Anything that was under it before stays under it. So the 3 and the x squared stay under the cube root symbol. The 4 and the x1 were able to come out of the cube root symbol and are in front of it. This is your final answer. If at any point you got any of these parts wrong, please revisit that part. Please identify the spot at which the mistake happened. If you don't understand how to do part of this, please watch that portion of the video again. If you need help simplifying the cube root of 192, go back to the day 1 video and rewatch simplifying cube roots, which was the second half. We're going to move on to simplifying square roots and cube roots that have more than one variable. So we're going to have x's and y's in them. So if you need to rewatch any portion of this video, now would be a good time. Okay, this is going to be a mixed review. You will notice that the 3 problems on the left on the first column are all square roots. The 3 columns on the right, the second column, are all cube roots. So when we're solving these, always pay attention to whether there's a 3 there or not. We're going to start with the very first problem. I'm going to separate this into the square root of 25, the square root of 2 x's, and the square root of 4 y's. Anytime you have a new letter, you're going to break it apart into a new square root. I'm going to do this the same way I have been. I'm going to start with 25. If you don't know the square root of 25, you can use the button on your calculator. For square roots, your button is second, and then the x squared button is the 5th one up. So the square root of 25 in my calculator is 5. X squared, because I'm dealing with square roots, I'm going back to groups of 2. For the x's, I get one group with nothing left over. Let's move on to the y's. Groups of 2 again. For this, I get 2 groups. So I have y2 with nothing left over. So my final answer, you could take all of these and write them closer together, or you can leave them just like this, but they are all together. It's 5xy squared. Once again, that exponent of 1 is optional. If you choose not to write it, that is fine. We'll do one more together, and then you'll finish the last 4 on your own. After the next one is done, please pause the video so you have time to work on the last 4 problems, as the answers will appear shortly on the screen. Okay, I'm going to break this one into, do the bottom right corner. So the cube root of 648, x to the 5th, y to the 8th. So I'm going to do the very last problem. I'm going to break this into the cube root of 648, the cube root of 5x's, and a cube root of 8y's. The cube root of 648 is not a perfect cube. So I'm going to have to simplify this using my list of perfect cubes. So over on the side, I'm going to make my list of perfect cubes. My bottom number is 8. That's 2 times 2 times 2. Then 3 times 3 times 3. 4 times 4 times 4. 5 times 5 times 5. And keep building your list up. You need to build your list so that it goes higher than 648. So now I can stop my list because 648 fits in between. I'm going to start dividing. 648 divided by 512. I'm going to keep dividing until I get a whole number. I notice that 648 divided by 216 equals 3. So I can separate 648 into the cube root of 216 and the cube root of 3. We know the cube root of 216 is a perfect cube because it's in our list. So I'm going to go back to my calculator and find out what the cube root of 216 is. My calculator tells me it is 6. So I have 6 cube root of 3. I have finished with 648. I'm now going to move on to my x's. I'm dealing with cube root again, so I'm going to circle that 3 up there to remind myself to put my x's into groups of 3. So I get 1 group and 1 extra. So I have x1 and I have a cube root of x1. Now we can do the y's. Once again, I'm going to circle my 3 to remind myself to put them in groups of 3. 1 group, 2 groups, and I have 2 extra. So I have y squared cube root of y squared. So to write my final answer here, I know it's a lot of work, so try to just keep it organized. To write my final answer, I'm going to take all of my numbers that are not inside of a cube root. So my 6, my x1, and my y2. I'm going to write all of those. 6, x1, y2. Then I'm going to draw a cube root symbol. And all of my numbers that were inside of cube roots are going to go here. So 3, x1, y2. This is my final answer. When you're working through these, take them slow, do one thing at a time. Break your original problem into the number, then the x's, then the y's. Simplify the number first. If it's not perfect, make your list. For square roots, use your list of perfect squares. For cube roots, use your list of perfect cubes. Once you have simplified the number, move on to your first letter. For square roots, use groups of 2. For cube roots, use groups of 3. Once you've done all of the groups individually, you're going to put them together into one answer. All of the numbers on the outside of the square root will go at the front. All the numbers on the inside of the square root will go together underneath the square root. If you need additional time to work on this, please pause the video, as the answers will appear on the screen in a few minutes. At this point, if you need additional time to work, please pause the video. The answers will be appearing on the screen in just a second. Okay, please check your answers. If you got anything wrong, please look at the work I have shown. If you have an issue with simplifying the number, please look back at the day 1 review. If you had an issue with simplifying the letter, double check to make sure you wrote the right number of letters. Sometimes we forget one when the numbers get higher. And also make sure for square roots on the left side, you put them into groups of 2. And for cube roots on the right side, you put them into groups of 3. This is the end of day 3 and the end of simplifying square roots and cube roots. Thank you.